Hi everyone. So there will be some questions on statistics definitely in your exam, and there will be questions on formulas based question like the sensitivity, specificity, PPV, and NPV. So whenever you get a question on your based on a formula, so first there will be a long question, okay, 3-4 sentences, and the last sentence will be find out the specificity or whatever be the question. So read the last line first, okay, and when you have read what is the purpose of the question, what are they actually asking for. Once you find out whether they're asking for sensitivity, specificity, don't read the whole question first. In our statistics, first go to the what they are asking for, read that part first. Once you have read that, make a table, start making a table while you are reading the question. And how do you make a table? You have to make a table like this. So don't read the question first read what they're asking for, because you have to make the table accordingly. So you make a table, okay. So you need to classify who have the disease, who don't have the disease, and whether the test is positive, test is negative, and how many patients have test positive and all. They will give you some value and you have to subtract by 100 to get the remaining, or you have to subtract with the population. They might have given the total disease and you have to subtract. So they won't give you all the four values. You need to subtract from, suppose they will give you the out of the 50 patients, they will give you 35 have the disease. So you need to find out this will be how much will be this, okay. So just know they won't be giving all the values, and if you have the table, you know which values are missing and you can easily calculate by subtraction and addition on. So first thing is, once you have make a table like this, then comes the role of calculations. So if they ask you about the sensitivity, sensitivity basically means that among the patients who have the disease, how many are going to actually, if the test is positive, how many actually have the disease, okay. The sensitivity basically means true positives by true positive plus false negative. So we have to take into account this part of the column when there is a discussion on sensitivity. Only the patients with the disease, how many of them have the test positive, how many have the test negative, and among the patients who have the test positive, how many actually have the disease, that is the true positive. So remember, when we talk about sensitive, talk about the patients who have the disease, okay. When we talk about the specificity, we are talking about the healthy population, okay. We don't talk about the disease patients now. We talk about the healthy population. And what are we talking about? We talk about among the healthy population, if you do that test, how many are actually going to test negative. So suppose you do a test and you find the test is very sensitive, specific. Suppose you do a test to detect UTI in healthy population. You do a nitrite test in the urine. You know that the nitrite has high specificity. That means if you do this test in a patients in a healthy population, you are going to find that most of them who don't have the disease are going to test negative for the test. So if they don't have the disease, the test will be negative. That's the specificity. How do you define it again? True negative by true negative plus false positive, false positive. Yes. So we are talking about this part of the column when we talk about the specificity. So remember, in our sensitivity and specificity formula, we are not including the whole population. We are including a subpopulation, that is in a sensitivity, the disease population, in a specificity, the healthy population. Okay. But how is it different from positive predictive value and negative predictive value? So in a positive predictive value scenario, what we are doing is basically we are including the patients who are testing positive. So we are including this time all the patients who have tested positive, and we are dealing with both the disease population and the healthy population now. So basically, a positive predictive and a negative predictive value, they are going to give information on the prevalence, or they are related to the prevalence of the disease. You should know this point. PPV and NPV are going to be related to the prevalence of the disease, since we are talking about both the healthy and the disease population. So it's very simple to talk about positive predictive value. That means if a test is positive, how many of them are actually having the disease. For example, so to test for the formula for a PPV, it's a true positive by true positive plus false positive. Okay. So we are just dealing with the positive test now, and we are including both the disease and the healthy population. Similarly, for a negative test, what we are basically including, we are including for a negative predictive value, we want to know if the test is negative, how many actually don't have the disease? How many are actually negative? That is true negatives by true negative by plus false negative. Okay, so we are just talking about negatives when there is a negative predictive value. We are just talking about positives when there is a positive predictive value. How is it related to the prevalence of the disease? There can be a question on this and you should know. Suppose you decrease the disease prevalence. Suppose there is a situation where the disease prevalence decreases. Okay. So if you decrease the disease prevalence, what will be its effect on the positive predictive value? Now, if the disease prevalence decreases, definitely the number of the patients will decrease actually who have the disease. So the number of the patients who have the true positive, that will also decrease. And if you have less disease in the population, you are more likely to pick up more false positives. Okay. So the true positives will decrease with the decrease in the disease prevalence. So if the disease prevalence is less, what will happen to this ratio? Even the positive predictive value will decrease. What will you do if there is a disease prevalence is decreasing? What happens to the negative predictive value? If the disease prevalence decreases, the number of the patients with the true, since see, try to understand, number of the disease patients are less, therefore the false negatives will also be less. Okay, the true negatives, there will be more since the healthy population are there more, so true negatives chances will be increased. So the negative predictive value will increase. I'll just show you this slide, then you will be slightly clear about it. Now try to understand this. PPV and NPV, they are related to the prevalence. Okay, now how is it related to the prevalence? If the PPV decreases, now what happens if the prevalence decreases? The positive predictive value has to decrease because there will be more false positive for every true positive, because the total number of diseased patients are decreased. So you're going to find more patients who are false positives. Okay, so this true positive will decrease if the prevalence decreases. Similarly, in a negative predictive value, that will increase because there will be more true negatives. Okay, I know this might be slightly confusing. Try to understand, try to think that the overall disease burden is decreasing, prevalence is decreasing. Therefore, healthy population, now if you're doing a test, finding it negative on a healthy population, therefore you're going to find more negative tests. Okay, so the true negative will increase definitely. And if the true negative will increase, this will increase. So if the numerator increases, then the negative predictive value has to increase. So there can be a tricky situation on this. Specificity, sensitivity is not affected by prevalence. PPV, NPV are affected by the prevalence, because in this we are talking about both the healthy and the disease patients. Once we have done with this, these can be the 4 formula-based questions you might encounter. Another thing is you should know about hypothesis. Now, what is suppose we take a hypothesis. What is a null hypothesis in this situation? We'll take an example and understand this. Suppose we take a null hypothesis, that is radical prostatectomy and radiotherapy has equal incontinence rates. This is our null hypothesis. We take this null hypothesis and we do a study. Okay, and there can be another hypothesis, which is an alternative hypothesis, that is radical prostatectomy has more incontinence rates. Sorry, radical prostatectomy has more incontinence rates than radiotherapy. Okay, fine. So if we do a study and we find that radical prostatectomy has more incontinence rates than radiotherapy. Okay, if we do a study and if we find this is our finding, in that case, we have to reject the null hypothesis. Okay, if we have to reject the null hypothesis when our study finds that the radical prostatectomy has more incontinence rates than the radiotherapy, you will reject the null hypothesis because definitely your findings are not collaborating with the null hypothesis. So what will you do then? So you will level these patients at the true positives. Okay, you will, since you have done the study and found it statistically significant, your results, now you will consider that RP has more incontinence rates. But while you have done this study, there could have been some error in the study. Every study is bound to have some errors. Now, these errors could be because of some other factors. You might have found that radical prostatectomy has more incontinence. patients in radical prostatectomy arm has got more incontinence rates because of some errors in the study. These errors could be because of maybe these patients underwent previous TURP. Maybe these patients had a large median lobe. Maybe these patients had a large prostate size. So this could be the different errors which you might not have you might not have removed from the inclusion criteria. And so you found your study had inherent errors, okay, because you included these patients also, and these errors are known as the type 1 error. So what is type 1 error? Try to understand. Your study finding was rejecting the null hypothesis, but there will be some patients in your study which were actually supporting the null hypothesis. If you remove these factors, probably there will be some patients in your study who actually support the null hypothesis, that is radical prostatectomy and radiotherapy have equal incontinence rates. Probably. Now, in that case, your null hypothesis could have been true, but you have rejected it. Why? Because of you have not removed these factors from the study. Now, so these errors which lead to rejection of the null hypothesis is known as the type 1 error. Now, what is happening in type 1 error? Why it is called false positive? Because there are certain patients who actually have a radical prostatectomy and radiotherapy incontinence rates similar, but you are finding them different. Okay, you are finding a difference, that is a false positivity in their results. And this kind of error that you are encountering in your study is the type 1 error. So just think it again. It's not very difficult. Type 1 error is when there is a false positive error. Your study have some bias. Your study have some inbuilt error, which might have led to a different hypothesis, a rejection of your null hypothesis. And so you encountered this error. Okay, so this is a type 1 error. It's a false positive error. What about the type 2 error? Similarly, suppose you have done a study again, this time you found that radical prostatectomy had incontinence rate similar to radiotherapy. Okay, so this you found that the null hypothesis was true. It's a true negative, that is there is no difference. Okay, so you accept. Fail to reject means you accept the null hypothesis because definitely your outcomes are true. But again, there might be some patients in whom the radical prostatectomy might have more incontinence rates than radiotherapy. There will be some patients in your study which you might have falsely found there is no difference. Who are those patients? Probably you have done a nerve sparing radical prostatectomy that improved the outcome. Okay, that improved the continence rates. So that's not supposed to bias your results, but there are some inbuilt error in your study, like you preserved additional membranous urethral length. So all these factors which make your study, the radical prostatectomy and radiotherapy incontinence rate same, but actually there is not same. Actually, the null hypothesis suppose has to be rejected, but you accept them, and this type of error which is there in your study is known as the type 2 error. And what is type 2 error? It's a false negative. That means you there was supposed to be a difference in the finding, but you are still accepting it. Okay, so these are the false negative errors which you are supposed to which is there in your study if you are accepting the null hypothesis, but there is a difference. For your MCQs, you need to know type 1 false positive, type 2 false negative. MCQs might not be so simple. You need to plot this, okay? You need to know what the hypothesis is. So you have to spend time on your statistics question. So whenever there are statistics question in your exam, there are around 2 to 3 questions. Please spend time on them. Don't just give up the questions. They are not very difficult. You have to plot them in a table. The first thing is read the last sentence first. What are they asking for? Okay. And when you get all the information, try to jot them down in a table. That's the most important thing. Type 1, type 2 errors can be important. Which one is false positive, which one is false negative? This is important. Okay. Now, test of significance is another thing. I got this from one of the books. Just keep it very simple. Okay. What are the different tests of significance that we need to know? One is a parametric, other is a non-parametric procedure. So parametric is something that we can measure. So what we can measure is the body weight, the BMI, non-parametric like the blood group and also which we cannot measure. So parametric, so first you find whether there is a parametric or a non-parametric value in the question. What are they asking for? So in this kind of situations, don't read the question first, read the options first. Okay. So there will be 5 options, read the options first. So these are the ways which will help you in solving the statistics question. Read the options, try to see what are the options, okay? Because you know the test for the parametric ones are very simple, okay? If you find, now when you start reading the question, you will understand what the options are. So they're basically asking for test of significance. So you will be looking for whether they're asking for parametric or non-parametric. So once you have found, you will be, when you're reading the question, try to find out whether they're comparing. So I'm writing it down. So this is one group, okay? So that means in the one population, one person only, you are checking the BMI before exercise and after 6 months of exercise. You are checking the PSA before starting the dutasteride and after starting that 6 months of dutasteride. So these are known as the paired t-test, where you have something to measure a value. For example, a PSA before and after starting dutasteride for 6 months. So you are doing it in the same patient before and after, the single person. Okay. So single person, you're doing it. That's a paired t-test. Okay. And the same thing you are measuring, it's not the PSA. Suppose you are measuring the some gene. Okay. You are measuring some gene before and after doing something. So in that case, if you are doing it something which cannot be measured, a non-parametric value before and after, use the signed rank test. Okay. Remember, sign rank test. Okay. So this is also for one group. Sign Wilcoxon signed rank test. Okay, they can just give you signed rank test. So remember this, write this one capital. So signed rank test is for one group. When there is two group, same thing, when you can measure, it becomes a unpaired t-test. Before and after, but in different groups, two groups. Okay, then it is the unpaired t-test. Same in two groups, it is rank sum test. Okay, why sum? Because sum is not for one, sum is when you are adding up. So rank sum is for not for one group, it's for two group. So this is how you can remember it till your exam day. And Wilcoxon rank sum test is for two groups. Now when you have three or more groups, so again for two group, you also, sorry, for one group, you also have one more test, that is a McNemar test. Okay, for one group, there is also another test, McNemar test. And so two group, Wilcoxon rank sum test. And for three groups or more, we have ANOVA, that is for parametric values. Okay. And for a non-parametric, we have Krustal values and we have chi-square test. Now, if the chi-square test again, if you find, suppose you are testing the PSA values of 40 patients, okay? So when it is chi-square is, when the N is less than 30, okay? That is when it is more than 30, you use, chi-square is when N is more than 30. When N is less than 30, you use the Fisher exact text. Okay, so chi-square, Fisher exact, three or more groups, and these all tests will come. You just need to memorize them. There is no way. And when you are asked to determine correlation between two variables which you can measure, it's a Pearson coefficient correlation. And when you have to define correlation between two groups which you cannot measure, it's non-parametric group. That's a Spearman's rank correlation. So for your MCQs, you need to memorize them, and there will be questions on them. Test of significance is put up as a question. So remember, just remember, there will be, remember the formulas for the different statistics, sensitivity, specificity, PPV, and PV. Remember the errors, the type 1 and type 2 error. And remember the test of significance. These are very important for you this statistics. Also remember the just go through the level of evidence once, so you can expect questions from all this. Okay, so thank you and all the best for your exam. And if you have any question, you can drop in the comments. Thank you.